Okay, today's lesson is one that's more theoretical than the ones we've been having. So far, we've been having more of a practical outlook. Today's one is going to be looking at the theory behind it. Now, it's important to understand theory because A, you're doing a master's course, and B, the theory actually explains or attempts to explain practical realities. Now, one thing you got to understand is that when you were in school, you would have been taught various theories in your textbook, and you basically accepted them as they are or as they were. But in reality, theories do change. You can have a theory that comes into existence, attempts to explain something that is real, but can be contradicted, can be disputed by another theory. So the theoretical world in which we operate tends to vary, and you can question these theories. You can question the assumptions of these theories. Now, today's lesson is going to be very important for your first assessment, where you're writing a paper on prospect theory. Now, I like to keep things intuitive and to sort of keep things accessible to you. So I'm going to keep it as simple as possible, and I'm going to let you build on that when you do your first assessment. We return to the basic gamble that we started with, which is the probability of a coin toss. Do you remember this? Yeah. You have a coin. You toss the coin. And there are two outcomes that are possible. Either the coin lands heads or it lands tails. If it lands heads, you get a certain payout. If it lands tails, you get another payout. Now, I just want to focus on the probability aspect of it, because we're dealing with decisions that are uncertain, meaning we do not know what's going to happen for sure. Right? And therefore, when we are calculating the values of the possible outcomes, we have to consider the probability that it may happen or may not happen. Now, if you have a fair coin, now the word fair is quite important here because it means it's not biased. There's no probability that the heads will turn up more than the tails. There's an equal chance of the heads turning up as much as there is the tails. So if you have the probability of a fair coin toss, the probability of a fair coin toss is 50% of the time. There's a 50% chance that it'll turn up heads, and there's a 50% chance it'll turn up tails. Okay. That's what these probability values are. Now, what I want to do is I want to take you into the concept of the multiple coin toss. That is, you're tossing the coin several times, not just once. Let's say you have a gamble, you have a game in which you're tossing the coin 3 times. What is the probability of it turning up heads on all 3 occasions? How would you calculate that? So the probability of it turning up heads on all 3 occasions is the probability of it turning up heads on the first occasion and it turning up heads on the second occasion and it turning up heads on the third toss. So it has to turn up heads on all 3 tosses. Okay. The way we would calculate the probability of it turning up heads on all 3 tosses is the probability of it turning up heads on the first toss times the probability of it turning up heads on the second toss times the probability of it turning up heads on the third toss. So the probability that a coin tossed 3 times turning up heads on all 3 occasions is 1/8. Do you get that? Okay. Could you calculate the probability of a coin turning up heads if we were to toss it 5 times? What would be the probability of it turning up heads if we were to toss the coin 5 times? Could you work it out right now? 1 over 32. So we can just simply extend this. Half times half times half, that's for 3 tosses, times half times half. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So it's equal to 1 over 32. Okay. So the probability of it turning up heads on all 3 tosses, on all 5 tosses, is 1 over 32. Okay. So that's how you calculate the probability of a coin toss on multiple occasions. Now, remember we said that when we're dealing with risk and uncertainty, when we are looking at considering 2 risky options, we cannot simply factor in the value of the return or the value of the outcome. We also have to consider the probability of the outcome. In accounting, for example, you're used to calculating simply the value of the possible outcome. You invest and you calculate the present value of that outcome. But if you're considering a very risky investment, a risky project, you have to factor in the chances that things will not materialize the way you want it to materialize. And this is where you have to incorporate probability. Now, once you incorporate probability into the value of the outcome, you wind up with what we call the expected value. So it's the value of the outcome times the probability of the outcome. Okay, and here we return to the game of the coin toss. Let's say if every time it turns up heads, you win a pound. You gain a pound. Let's say this is a game, and in this game, every time you toss a coin and it turns up heads, you win a pound. Now, we know it's not going to turn up heads all the time. There's a chance that it'll turn up tails. So here we have an outcome that has a degree of risk. So we need to evaluate, we need to measure this risk. One of the earliest measures of risk was the expected of value under risk is expected value. This is where we combine the probability with the expected outcome, with the outcome. So in our little game, the probability of it turning up heads is half, and the reward or the outcome of heads is 1. So 1/2 of 1 pound is equal to 50 pence. So the expected value of a coin toss, in which you get 1 pound every time you win, every time you gain, every time it turns up heads, is 50 pence. Okay. Now, let's extend this to 2 tosses. Let's say we have a game in which the payoff is still 1 pound if it turns up heads, but it's not based on 1 occasion, it's based on 2 occasions, meaning that it has to, we get 1 pound for every toss, provided there are 2 tosses. So we toss the coin once. If it's heads, we win 1 pound, and we toss the coin a second time, and if it's heads, we win 1 pound. Now, what is the expected value in this game? Well, the first coin toss, the probability is half times 1 pound. The second coin toss, the probability is quarter. Why is it quarter? Because we have to get half times half, because this is the coin toss. So we're looking at a coin toss in which we need heads to appear both times, right? And in this case, it's quarter of a pound. So half of a pound is equal to 50 pence. Quarter of a pound is equal to 0.25 pence. So the total expected value in this game is 0.75. Okay. Now, let's go to a bit more of a bit more sophisticated. Let's extend it. Let's extend that concept of expected value on multiple tosses a bit more. Let's say we have a jackpot of a pound. Anybody here plays the lottery? No? Nobody here plays the lottery? Which makes my next question redundant. I was going to ask, anybody won the lottery? No. The jackpot starts with a £1, with £1, right? And it's doubled every time a head appears. So you start with the jackpot of £1, and every time a head is tossed, it doubles in value. So you have £1. It increases by £1 if you get a head on the first coin toss. It increases by £2 if you get a head on the second toss. £4 if you get a head on the third toss. £8 if you get a head on the fourth toss. Do you see how it works? It's doubled every time you get a head on the sequential toss. Now, we're not going to consider the possibility of it winding up tails, because if it winds up tails, then it doesn't work the same way. So we're just going to focus on the reward system here. Now, the expected value, therefore, is what is the probability of a head appearing on the first toss? Is 50-50 times the value you get if a head appears in the first toss. What is the probability of the head appearing on the first and the second toss? 50-50, 50, 0.5 times 0.5, which is 0.25, a quarter, right? And what is the reward if it happens on the second toss? You double the original jackpot. Okay. What is the probability that the head appears on the first, second, and third toss? 1/8, right? We saw how that worked out. And what is the reward if a head appears on the first, second, and third toss? You double the previous jackpot, and the previous jackpot is 2 multiplied by 2 gives you 4. Okay. And what is the probability of a head appearing on the fourth toss as well? 1/16. And if that happens, you double the jackpot again, and so on and so forth. Right? Now we can take this to to infinity. So, what is the expected value of the first toss? Half. What is the expected value here? Half again. What is the expected value here? Half again. What is the expected value here? Yeah. Now this is what we call now what you're seeing here is that in this game the expected value on each toss is half. And if you do this infinite number of times, the expected value will still be half. Right? Now this was presented at a conference in St. Petersburg, Russia, by a French mathematician called Nicolas Bernoulli back in 1738 or thereabouts. I forget the exact date. And this is what we call the St. Petersburg game. Because here you have a game in which the expected value is half for infinity. Now in mathematics we don't like infinity, because infinity doesn't really give us any definitive value, and that is what's interesting about the St. Petersburg game. That if you were to play this game, the expected value, the expected value of your outcome is infinity. You can make infinite amount of wealth, because every time you have a 50-50 chance of winning. If you keep gambling, there's an infinite chance that you will win. So the question really is, how much would you be willing to pay to play this game? Given the fact that you can, you have an infinite possibility, your possibility of your expected value is infinity. What is your, how much would you be willing to play this game? Now, when this was examined, what the researchers found, when people were asked this question, when people were given the opportunity to play this game, what they found was, despite the fact that the expected win is an infinite sum of money, people were not willing to pay a large amount for this to play this game. The price that they were willing to pay was very limited. A more recent paper in 2004 found that people are willing to pay, they're not even willing to pay $25 to play this game. Now, this led to what we call a paradox. A paradox is something that appears very simple, but it's not, right? And the paradox here is that if you have a game in which the expected win is infinite, you should not really have a constraint on the cost that you're prepared to invest in order to play this game. Is a bit like saying, here is an investment opportunity where the expected win, where the expected return is infinity. There's no limit to the amount of returns that you can make. But people still don't take it. People still place a lower valuation on it. So the question is, what's going on here? Why is that? And that led to what we call the St. Petersburg paradox. Now, in answering, several mathematicians, several economists started sort of, studying this problem and saying, why is that? Why does the St. Petersburg paradox exist? And one of the theories that came out of this, or one of the theories that attempted to explain the St. Petersburg paradox, was something called the expected utility theory. Now, expected utility theory was formulated by another mathematician called Daniel Bernoulli. Does the name Bernoulli mean anything to you? Do you remember the guy who came up with the St. Petersburg paradox? What was his name? That was Nicholas Bernoulli. The guy who came up with expected utility theory is Daniel Bernoulli. They're cousins. Okay?
So he's also from France.
Yeah, they're French. Now, Daniel Bernoulli is actually credited with coming up with expected utility theory, but as with many theories, you will find that other people would have thought about it, and this is the one person publishes it, and then that person winds up with all the fame. So I'm not gonna go into details, but for your purpose, Daniel Bernoulli is the author you're looking at in terms of expected utility theory. Now, how he explained this was the decision is not based on the outcome itself. So when people were looking at making an investment decision, they were not looking at the outcome of the expected decision. They were looking at the utility derived from the outcome. Now, this was a new dimension that we did not know, we had not thought about it at the time, and this was in the 18th century. We had not really thought about that, the concept of utility and not outcome. We used to have a very, the economists used to have a very linear perspective or mathematical perspective in defining valuation. So here we have a situation where he's saying that when people are making decisions, is not really the outcome that matters, it's the utility that they derive from the outcome. And the best way you can sort of picture utility is satisfaction. So what he's saying is that, in other words, what he's saying is that people, when they make decisions, they're not really looking at the outcome of the decision, they're looking at the satisfaction derived from that outcome. Okay. And here you have, now that is what you can call utility theory. So this concept, this idea that the outcome itself is not what's looked at when you're factored in, when you're looking at the decision, is the satisfaction you get from the outcome. Now that's something you can call utility theory. Now the St. Petersburg paradox was based on decisions or outcomes that were risky, where you did not have any certainty over the outcome. Now here you have an element of risk and uncertainty. So we transform utility theory into expected utility. So here is not simply utility, it's the expected utility. So there are three dimensions to this. It is the outcome. So if you can look at the three dimensions, I'll do it on my x, y, and z axis. Here you have the outcome, the utility from the outcome, and you have the probability or the risk. So these are the three dimensions we're playing with now when it comes to decision making. So even in your situation where you are making a decision about what to invest in, whether to invest in it, what time you're investing in it, your decisions are based on these three dimensions. I mean, these theories actually, you can actually see these theories applying to your decision-making process. Now, therefore, what expected utility theory says is that the subjective value of a gamble is based on the individual's valuation of expected outcomes. So the outcome itself is not what determines the decision. Is the individual's valuation of the expected outcome. So even if you were to calculate the expected value of an outcome, that gives us very little by way of how people will make decisions, because people don't make decisions mechanically based on the expected value. They make decisions based on the satisfaction they derive, they attach to the, or the utility they attach to the expected value. Okay. Now he contributed quite a lot to the to utility theory, and I'm just going to give you a primer on utility. He was basing it on expected wealth. My lines are not clear because I still am not that good at art. So this is the, if you can consider the y-axis, sorry, the x-axis to be the utility, and the x-axis to have expected wealth. So the expected wealth, or the financial outcome, is plotted on the x-axis, horizontal axis, and the y-axis actually contains the utility. So as a person, what do you think will happen? As a person expects to gain more and more wealth, what will happen to utility? It'll go up, right? So as a person's, actually, let me just get rid of expected wealth, and let me just put wealth there so we keep it simple. Okay. So we can assume a person has a certain level of wealth, and he or she is expecting to get more. What happens to utility as persons get more and more wealth? We expect the utility to keep on going up. Now, what he argued was that utility will go up, but it'll go up like this. What does that mean? That means the satisfaction or the utility is going up as a person is expected to get more and more wealth. But as a person has more wealth, the additional satisfaction they get is limited. Let's say currently you have a salary of, say, students. Well, I don't know what a student salary these days is. Ours was very, very minimal. Let's say you're earning a monthly salary of £1,000, and somebody just said wow. So okay, and somebody tells you, I'm going to I need you to do a small job for me, and I will pay you £700. How much would that be worth to you? A lot? Would that make much of a difference to you? Would you consider it to be significant? Yeah. Now imagine that you've graduated and you've got your city jobs, and you're earning, say, something like 320,000 a year, right? And somebody tells you, I'm going to give you £700. What do you think? That £700 doesn't make much of a difference to you, right? And the reason for that is you already have enough of it. So the more you have of it, the extra satisfaction you get, extra utility you derive, becomes less and less. And that's what this curve shows. That's why it sort of flattens out at the top. As your wealth grows, the extra satisfaction you gain grows, diminishes. And this is a principle which we call diminishing marginal utility. Now, marginal utility is the additional utility we gain from one extra unit, or one increment. If you increase wealth by 1 unit, let's say £1, what is the extra satisfaction you get? What is the extra utility you get from that extra £1? Now, that question, that value changes depending on how much you already have, like we just saw in our case. So if you were to plot marginal utility, what you see is that as the wealth increases, marginal utility actually diminishes. So you have a situation where the extra utility you get, or the marginal utility you derive from an increment in wealth, actually diminishes as your total wealth increases. So this is why they say money to burn. It used to be the case that in the old days, very rich people would light their cigarettes with a dollar. They would put the dollar to the candle, and then they would light their cigarettes with a dollar. Right, money to burn. Okay. Now, there's another concept of indifference, and I'm not gonna confuse you by drawing any more graphs. But the concept of indifference is
So regarding the law of diminishing marginal utility, I want to refer back to the example that you gave, wealth and utility. But there's also a belief that humans are insatiable when it comes to wealth.
Humans and
Insatiable when it comes to wealth. How do we relate that to wealth marginal utility when it comes to wealth?
Human insatiability. Yeah.
I said there's a belief that humans are insatiable when it comes to money.
Yes.
Wealth. So I want to refer you back to the example that you gave. So when it comes to utility and wealth, how do we?
There is this other concept that Bernoulli also contributed or spoke about, which is this concept of indifference. When you say indifference, what does that mean? Exactly. I mean, if somebody were to say, would you like, you go to a party and somebody says, would you like a Coke or a Pepsi? And you say, doesn't matter. You're being indifferent. Whether they give you a can of Coke or whether they give you a can of Pepsi, it's the same thing to you. You get the same satisfaction from it, right? You can actually apply the concept of indifference to risk and reward. Now, in your corporate financial management classes, you would probably have learned about the relationship between risk and reward. Yeah. There's this old saying that in order to gain a reward, you have to take on a risk, right? And the greater the risk, the greater the reward, the greater the risk, the greater the risk, the greater the reward, because of the risk premium. So if you were to take the risk on this axis and the reward or the wealth on this axis, an indifference curve would look like this. Now, don't confuse this with diminishing marginal utility, but in a way it is. What this shows is that we'll call utility 1. What this shows is that on any combination of risk and reward, actually I'm doing it the wrong way. Let's get the right way then. Sorry. This should be the other way around. Okay. So here you have the risk. Imagine these are straight lines, all right? Here you have the risk, and here you have the reward. So as your risk is increasing, you also want your rewards to increase as well. Now, let's say here the utility is 1, which means whatever the combination of risk and reward along this line, your utility is the same. Then you can draw another line, which is another parallel line, and here the utility is 2, which is along this line, whatever combination of risk and reward, your utility is different. So as long as we're sticking to this line, whatever the risk and reward, you are indifferent. You don't really care, right? Whether you're at this point, you derive the same utility as you are at this point. Now, this is a theoretical notion, and that's the concept of indifference. Now, more recently, in 1947, 2 people called John Newman and Oscar Morgenstern looked at the expected utility theory, and they asked a question, which is, within the concept of expected utility theory, what makes a decision maker a rational decision maker? Now, in behavioral economics and in economics and finance, it all boils down to the theory of economics and finance in many ways is hinged on this concept of rationality. What do we mean by rationality? Who is a rational decision maker? What is the difference? What defines a rational decision? So that was something that Bernoulli didn't answer at that moment in time, because probably he didn't really have much time. And that was a question that Newman and Morgenstern attempted to answer. Now they went about it very mathematically about it, but I'm not going to go deeply into the mathematics because it's not something that we want to is part of the course. But you need to be aware of what we call the one Newman Morgenstern result, or the axioms. They said there are 4 criteria, 4 axioms for a decision maker to be rational within expected utility theory. One is completeness. That is, their preferences are well defined. If you have 2 outcomes, A and B, either the person says, I prefer A to B, or the person says, I prefer B to A, or they say the 2 are equal. Right? You got to be very clear about your preferences. Either A is greater to B, or B is greater to A, or A is equal to B. A and B are equal. You cannot have anything else. Either this, either A is equal greater than A, or B is greater than A, or the two are equal. Okay? And that's what they call completeness. The second is something called transitivity. Transitivity is if there are three options and the individual prefers A to B and individual prefers B to C, then we know it should be that if they're presented with A or B, they would go for A. So if they like A better than B or B better than C, then it has to go without saying that if they have A and C as the two options, which should be greater? A should be greater. Okay. The third one is something called independence. Independence means that if you have one gamble which involves two decisions that is mixed with the third gamble, then the two should be independent of the third one. And that's somewhat related to transitivity. The last one, continuity, says that if you have a preference order where A is greater than B and B is greater than C, then the probability that B is equally as good is the probability that of A plus 1 minus the probability of C. Now, I wouldn't worry too much about it at this stage. We'll go deeper into it at some point later on. But right now, what I want you to take away with you is the idea of the VNM result and the four axioms that they expounded: the completeness, the transitivity, the independence, and the continuity. Okay, we'll be going a bit more deeper into that. Now, this was great. You know, this was fantastic, and we had a clear theoretical understanding of how people made decisions under risk and uncertainty, which we did not previously. We had the classical economic theory, which did not really tackle decision making under risk and uncertainty. And when Bernoulli came along and he sort of changed the playing field, he added the concept of utility, the decisions that people make when they're presented with risky options, being down to the fact that they value not the outcome itself, but the utility derived from that expected outcome. Okay. Then you had two Israeli psychologists who came along in 1979 and said, all of this is nonsense. Right? Kahneman and Tversky, two psychologists, 1979, criticized expected utility theory for being too simplistic. They proved that the way people make decisions, the way expected utility theory describes the decision-making process under risk and uncertainty is not valid, okay, or is dubious. And we actually held an experiment in class on the first day, which was based on Kahneman and Tversky's own research, didn't we? Remember that? Now, their ideas led to something called prospect theory. They published their ideas as under a paper called prospect theory. And prospect theory says that when people make decisions, they don't make decisions based on the final outcome, like Bernoulli said. They make decisions on the potential value of losses and gains. They don't look at what would I make, or what is the outcome of this decision. They would look at how much would I stand to lose, or how much would I stand to gain if I were to take this risk. They also proved, or they also showed, that the preferences of individuals are inconsistent given the same choices. And that was shown in this table that we actually used as part of the experiment in class. If you look at these two decisions here, number 6 and number 7, right? Here you have an expected value which is exactly the same, right? And here you have an expected value which is exactly the same. But when the sample that was surveyed in Kahneman and Tversky's 1979 study were given the choice of which one they would go for, they, on this occasion, most of them went for that, and on that occasion, most of them went for that, even though they were essentially the same gambles.
What was the, did it look more attractive?
That's the question that they were asking. You know, that's the question that they were asking. That here you had a situation where you had where you had the same gamble. You're taking on the same risks. But on when presented in one way, they went for one option. When presented in a different way, the same gamble, they went for a different option. You know, this wasn't a one-off. They actually repeated this with several options. And they found that when people were presented with different gambles, with the same gamble in a different way, they actually chose in different ways. There was no consistency with expected utility theory. In fact, what expected utility theory predicted was not how people were actually making their decisions. So, what did I do? Oh, there we go. Now, so therefore they concluded, or they asserted, that EUT was an unreliable guide to human behavior. What expected utility asserted was not a reliable guide to human behavior. And this led to the origins of a field of study which we call behavioral finance. And there's a whole journal of behavioral finance that you can find. I actually did my PhD thesis on behavioral finance. Okay. Now, and in fact, your first assignment is going to be on behavioral finance. Okay. Now, since the challenge to expected utility theory, the people who the academics who use expected utility theory, or who I mean the school of thought. I mean in academia, you have what are called schools of thought. You have some people who are they're a bit like political parties. You know, some people support the Lib Dems, some people support Labor. It's a bit like that. Some people support expected utility, some people support prospect theory. So in academia, you have these what we call schools of thought, and they sort of are opposite ends. The expected utility theory supporters, or school of thought, has not remained silent on this. They have come back and hit back at prospect theory, and they have argued that expected utility theory is not completely useless. It still has applications today, right? One of the amendments they made was this concept of bounded rationality. And that's something that they accepted, that when they defined rationality, and especially when Newman and Morgenstern defined rationality in their 4 axioms, they agree that those axioms were rather simplistic. And rationality is not the kind of rationality that's defined by mathematical formulae, but it is something called bounded rationality. And that is to say that the decisions of rational people is limited by the information they have, their cognition, You know what cognition is? Cognition is how your mind processes facts. You know, when you're learning facts, that's called cognitive learning. Is the learning of facts. Cognition is the understanding, the processing, and the learning of facts. But there are limitations to our cognitive processing and time. So if you were to apply this to your decision making as traders, the information you have in order to make a trading decision, would you say you have 100% of the information all the time? No. There's limited information. In fact, you have less than 5% of the information you really would need to make that decision. Cognitive limitations. We talked about one of those cognitive limitations, which is when you make a trade and the trade goes south, it goes sour, you hold on to that losing trade for longer than you should, in the hope that it will go back up again. Right? Here you have a situation where your emotions are limiting your cognitive faculties. And time. Do you have sufficient time to make a decision? Right? When you're trading, you will find that you are constantly finding yourself under time pressure. You have to make a decision very quickly. But the time you have to get the right information, or the time you would prefer to have, is limited. So these factors actually limit the decisions of people who are rational. I mean, you guys consider yourself to be rational people, right? But your decisions are limited in their rationality, or in another word for limited is bounded, and that's how the word bounded rationality came into existence. And this was an idea that was put forward by Herbert Simon, where he said that people are not interested in optimizing their utility. They're interested in satisfying the utility. Now you'll explore that a bit more when you're doing your paper, your first paper. He also introduced this notion of heuristics. Heuristics is if you're making a decision, one impression that you get when you are making a decision in the context of an assignment or an academic or an exam is that you're given a set problem and there's a set solution, right? And you have to go through the various analytical processes to get to that point. So if you're asked to do, say, a present value calculation, there's a formula that you use and you apply the formula to your numbers. But in real life, you don't have that benefit. You have to make decisions in a non-mechanical way, what we call rules of thumb. Right? And the more and there be studies done of managers, and so you study how managers actually make decisions, and you find that many managers make decisions based on intuition. Intuition is a very prominent feature of managerial decision making. Whereas in your undergraduate studies, and even in some of your postgraduate studies, you're given the impression that when decisions are made, they're made very analytically, very methodically. That is not necessarily the case in real life, because the rationality is limited by the amount of information we have, by the cognitive limitations, the amount of time we have. So heuristics is an alternative to the mechanical rational decision making. It calls for the use of mental shortcuts, intuitive judgment, and common sense. And the advantage of heuristics is you don't have to think as much. It eases the cognitive workload. When we go into the neurological aspects of it, you'll see that different parts of the brain are used in different forms of decision making. And the part of the brain that's responsible for the analytical, conscious, cognitive decision making is also a part of the brain that is the weakest in the human being, even after so many millions of years of evolution. Okay, so that sort of is intended to give you a picture of the theoretical debate, and it is meant to be the starting point of your first assessment. Speaking of which, what is your first assessment? And that's something we need to look at. Now, the first assessment can be found in your module study guide, which you'll find online. Okay, it says here, since Kahneman and Tversky in 1979 challenged the main assumptions of expected utility theory, behavioral finance has, as an academic discipline, has contributed significantly to our understanding of financial decision making. Now that's a statement. You're asked to critically review the relevant literature. All right? You don't have to take this down. This is actually India Module Study Guide. Yeah? This is on page 12. Now, what does that mean, critically review the relevant literature? Let me break it down into two things. Well, three things, actually. One is the relevant literature. What is the relevant literature? When we say relevant literature in this context, what exactly do we mean by that?